students. I think in previous two lectures we have seen the concept of classless addressing and how to find out the different addresses in a block. Now one more topic is very important with respect to this, as we have learned in classful addressing, which is subnetting of network, right? So if you remember, in classful addressing we have divided our subnet into smaller networks with the help of predefined default subnet masks, right? To find out the network address and so on. And by default, class A, B, C subnet masks were defined. But now address is fully classless, right? So I think it can be easily understood like subnetting concept will be little bit different from there, like in addressing concepts. Okay, so how we can perform subnetting in classless addressing? This particular video will focus on this issue. So we know the subnetting philosophy of subnetting. One is to find out the network ID and destination address so that packet can be routed inside the network or outside the network, maybe internet or some other. And the second biggest thing is that if we want to divide our complex network into sub networks, like we have taken an example of, like in our institution, different departments are there, but for a global world, we are treated as a common entity. But now we need separate networks for our engineering departments or some other departments so that we can easily manage the traffic. One sub network's message cannot be going through with the all the other departments network. Suppose civil engineering department is sending a message to internally to their network, civil department, some other host or client, then it can be easily handled by their own subnet part, and that is the responsibility of the network router and server to manage this thing. And for rest of the world, if particular department interact with the outside world, then the common address of only one address will be displayed to the global authorities, right? But inside the network we have divided separate network addresses to our subnets so that things can be easily managed and handled. So how this particular subnetting will be implemented in classless, this we can discuss. So we all know in classless addressing, prefix length is the most important parameter, and I think in other terms we can also say it mask of this particular type of addressing scheme, because after IP address put slash and write some number is a type of or syntax of writing a IP address with mask, right? So start and finding the subnet mask, then subnet addresses, how we can find out the address, because we know and we have seen in previous video lectures that in case of classless addressing, internet authorities allot us a number of block a number of block of number of addresses, and first address and prefix length will be given to us. Rest we have to define by our own. And then variable length subnets, how we can define various size subnets. Maybe we are going to divide our whole network into 4 subnets, then two cases may be there. We can equally divide the subnets in equal number of hosts, like every subnet will have 64 hosts, or maybe we can make it variable, like two subnets will be of 64, one is 32 and one will be 8. It's an example. So this philosophy will be considered in VLSM, right? So now we will see this particular overall topic one by one. So in fixed length subnetting, we'll start with fixed length subnetting means in every subnet number of hosts will be same. The number of subnets is a power of 2. How this will be implemented, now you can see it with the help of example. We can easily understand. An organization is granted a block of address this and subnet with this, or maybe prefix length, and the organization need 4 subnets. what will be the subnet prefix length. So if we find out, then the formula we can use log base to 4, then we will get 2. So we have to add 2 more bits into the prefix length or subnet mask, means 2 ones. To take a bit from or add into a bit into subnet means we have to add 2 more ones, because we know prefix length defines the number of ones in a 32 bit address. So the side prefix will be 28 for subnets, find it for subnet. Okay, now if we see the arrangement of this particular network, now we can see this particular predefined address which is given or allotted to us will be the site address, main address for the global world, which is assigned. Then for first subnet, you can see address will start from 64 and /28 will be the mask for subnet, first subnet. Then after 64, we know first address will be for the network address. Then after that, we will allot the addresses to the client. Then 65 and so on till 78. Right? Two different other addresses are also used for interfaces between routers, and the last address is 78 for the host. Then you can see this is the number 1 subnet, this is number 2. And if you see, the second subnet will be network address is 80. Where is 79? 79 will be the last address of this first subnet, because we know first and last is for special purposes. First is for network identification and last is for broadcasting and some other purposes. So 79, after 79, next subnet will be start from 80, then 81 allotted to a first client and so on. After this, some router addresses are also there. Then third subnet will start from 96, means 94 for the last client, 95 will be reserved for broadcasting, and 96 will be the, and so on. Similarly, fourth subnet will be divided in this way. So you have to find out each and every address range of this subnetting process. And now you can see equal number of clients are there in each subnet. So this is known as fixed length subnetting. Okay, how we will calculate it? Now the site has 2 to the power 32 minus 26, the default address given. 64 total addresses are there, and in subnet we can find out the addresses. The previous formula we have used in last lectures. 2 to the power 32 minus 28 means 16 addresses per subnet. Now find out the first and the last address in each subnet. So first address will be given as this, we have seen. Last address we know very well, 16 addresses are there, so 16 minus 1, 15. So add this 15 into this 64, you will get 79, the last address of first subnet. Okay, and then left 79 because of special address of first subnet. Then start first address of second subnet is from 80, then add 15 into it because equal number of hosts are there, then we'll get 95. And then similarly third will be start from 96, add 15, you will get 111, then 112, add 15, 127. So in this way we have find and allot the total allotted address block into 4 fixed size subnets, and we can easily calculate the first address, last address, number of addresses, and so on. So this is the method of subnetting in fixed length subnetting in classless addressing, right? Now make it little complex, or we can discuss now variable length subnetting or variable length subnet masking. Now see the question very carefully. An organization is there and address allotted, beginning address is this given to you, means there are 32 minus 24 equal to 256 different addresses are available in the block to assign different hosts, but organization wants 11 subnets. Mind it, we need 11 different subnets, and each of different size, like 2 subnets of 64 addresses, 2 subnets of 32 addresses, 3 subnets of 16 addresses and 4 subnets of 4 addresses, means 437 to 9 to 11. 11 subnets are required. How this particular situation will be handled, right? And now we can see, we can clearly say it's a variable length subnetting question because all the subnets have different number of hosts, right? So first see the arrangement. First address will be your site address, which will be associated with the router, and the router is already attached with the rest of the network. And inside your network, 264 addresses subnets are there, then 232-bit, 3 subnets of 16 addresses each, and 4 subnets of this 4 addresses each. Now you have to define these subnets, find out the first address and then last address and so on, what we have did in the last example, but things are variable now. If we try to guess how we will implement and vary this number of host value or number of addresses value in different subnets, I think it's very easy. You can catch it if we focus on only one thing, prefix length, which is responsible to define the number of addresses, because we always find out the number of addresses in a block with the help of 2 to the power 32 minus n, prefix length. And now you can see 26 is a prefix length in this, 27, then 28, and 30 is there. So how we can calculate it? Now see, first we use the first 28 addresses. We use the first 128 addresses for the first two subnets, means 64 each. So now how we will find out 64 in 2 to the power 2 to the power 6 becomes 64. So 32 minus 6 means 26. So the subnet prefix length for this first subnet will be 26, as we have seen in this previous diagram, right? Now we use the next 64 addresses for the next two subnets, means 32 addresses each subnet. So 32 means 2 to the power 5, and 32 minus 5, 27. So the prefix length will be 27. Now you can see in the diagram 27, right? Similarly, we use the next 48 addresses, 16 addresses each. 16 means 2 to the power 4. 32 minus 4, 28. Now last 16, 4 addresses each. 4 means 2 to the power 2. So 32 minus 2, 30. So subnet mask will be 30. Now you can see in the diagram 26, 27, 28 and 30 will be the subnet mask for fourth subnet. So in this way, first you have to find out the subnet mask prefix length, right? So after this, finding the first address and the last address is the same process as we have seen in fixed subnetting process in last lecture or last example, right? So similarly, you can easily find out the number of addresses. You have a first address, then add number of addresses into the first address, then you will get the last address and so on. So with this, you can easily handle the VLSM methodology of subnetting in classless addressing. So this is all from this lecture. Thank you so much. Hello students. In the last lecture, we have seen the classless addressing concepts and how we can find out the first address in an allotted block, how many numbers are there, number of addresses are there in particular allotted block. Now today we will move ahead and find out the last address, how we can find out the last address of a given block and further things. So suppose, let's start with an example. In the given question, find out the last address in the block if one of the addresses 140.120.84.24/20, and we all know now this prefix length /20 is the key of this particular classless or a CIDR notation addressing of IP address. So a random address is given and you have to find out the last address. So what will be the procedure for it? We can see. So in this case, like previous examples, we have learned how to find out the first address, and the first address was this, and the number of address is this on the basis of 2 to the power 32 minus prefix length, right? To find out the last address, we need to add 4095 to the first address. Means what? 4096 minus 1. I think we have discussed so many times that first address will be the network address. So apart from this, because 4096, this first address is included. So that particular address is given at the time of the allotment of the block. So minus 1, and we have 4095 different addresses in a particular block which belongs to this address belong to this particular block. So now what will be the last address, value of last address? We have to find out that. So with the help of this number of address figure, which is 4095, we can find it. We can see 2 or 3 methods similarly like we used in how to find first address. So the first method is, we know that 256 base 256 mathematics or arithmetic is used in this particular addressing concept. So if we use base 256, I think everyone is very much aware of this base mathematics. Like if base is 256, then number will be divided by the 256 only in every step. So if we write 4095 as 15.255, how we get this number? If we divide 4095 with 256, then it will, the quotient part will be 15 and the remainder part will be 255. So we can write it in the IP address form 15.255. This is the philosophy of this base 256 method. Now we can add this number 15.255 to the first address of a block, which is given at the time of allotment, right? So if you want to find out the last address, you should know the first address and total number of addresses. Then we get 140.120.95.255 will be the last address of this given random address. Okay, so only base 256 mathematics is required, which is the concern. We can see some more easier methods too, so through which you can easily calculate the value of this. Now see the alternate method. Now write down the last 2 octets binary value of your first address, which is this. Then write down the 4095 number of addresses in binary and add these two values. Again you will get the same value directly, 95.255, if you convert this result into decimal. So this can also be a method through which you can identify the or find out the last address with the plus operation between these two, right? Now one more method is there, find the last address in the block if one of the address is this. Suppose random address is the given here and you have to find out the last address. So solution is very simple. Now if you see the prefix part, which is 20, right? So we can also say the mask of CIDR notation addresses. So in this case, mask has 21 and 12 zeros, total 32, right? Now complement this value. All the 21, 20 ones become 0 and remaining zeros becomes 1, and convert it into binary. Again you will get 15.255, the same value, and add it into the first address. Then you will get the last address of a given block, right? Now you can see the method. So in this method, a very easy thing is there. We know the prefix length value is based on 1. Put all the ones and then remaining will be 0. Then complement it and convert it into binary, and add resultant value added into the first address of a block. So in this way, you can easily find out the last address in a given block. Now find the block if one of the addresses is this. In such type of question, when only block word is used, then you have to find out three things. Number one, first address, right? Number two, last address, and number three, total number of addresses in a given block. In previous examples, we have seen specifically mentioned their first address, last address, or number of address. We can handle it separately. No, a simple question is there. Find out the block. So one by one, we will find each and every thing 1, 2, and 3. So we follow the procedure in the previous examples that we have seen that find out the first address, the number of addresses, and the last address. So to find out the first address, last three methods were there. You can use any one to find out the uh, first address, right? So if you see, we notice that the mask 29 has 5 ones in the last byte, obviously. So we write the last byte as the power of 2 and retain only leftmost 5 bit shown below. This can also be a method if we convert 202. Now you can see that 202 is the last part. If we write it down this, then leftmost 5 numbers are this. So if we convert it into binary, it becomes 200. Okay, so this will be your first address, or you can choose any method which we have learned previously. Then number of addresses, you know very well the formula, to the power 32 minus the prefix length value. So 32 minus 29 becomes 3, and to the power 3 equal to 8. Only 8 addresses will be there in this particular block. Now to find out the last address, it's very simple. We can use the complement method of the mask. Then 29 ones are there. If we complement it, then it becomes 0 and 3 ones are there. So it will become 7, because 3 ones becomes 7 in decimal. So now add this particular 0.0.0.7 into your first address, which is this. So the final last address will be 190.87.140.207 slash 20. Okay, so this is the method through which you can find out the process of finding the complete block detail, right? So this is the method. Now show a network configuration of this previous example. So you can create the diagram. The overall address block range is this 29. I think the value written in this particular slide was wrong. It will 29. Treat it as a 29. Now see the configuration. These are the addresses ranges from 200 to 207. 8 addresses are there. First address is always be a network address, which is your this interface address. Then after that, from 201 to 206 will be the addresses for host or client. And we all know the last address is also reserved for broadcasting and some other purposes. So we can't allot it to any host. So in this way we can configure our network, right? So this is the method through which in CIDR notation or classless addressing, which is very much useful to avoid the wastage of IP addresses, right? So this can be a question for you. You can find out with yourself, practice problem. And these are the few notes. If you can see in classless addressing, the last address in the block does not necessarily end with 255. Obviously, you can clearly see that in case of classful addressing class ABC, whatever address is allotted, every octet will start from 0 to 255, right? But we have seen in classless, last address was 207 or maybe something like that, because we are giving or allotting addresses in pieces or in variable size blocks on the basis of users need or demand, right? So in this classless inter-domain routing notation, the block 100 is defined by the first address and the prefix length. Always remember, the first address and the prefix length will be given to you when you go to the internet authorities for allotting address in your for your organization. So this is the overall CIDR notation concept which we have seen in two different lectures. Rest we will discuss in next. Thank you.